Good morning and welcome to our fourth and final speaker series of the school year. Just to give you a little background in case you haven't been to one of these events, the speaker series events are hosted through Kenston Inc. And the Inc. is an acronym. Their mission, the mission of Kenston Inc. is to innovate, nurture, and connect. So our whole goal with this organization is to provide our students with authentic, real-life learning experiences and to help them prepare for college and career readiness, like after high school. So today we are fortunate to have a very expert panel that use statistics in their everyday professions, and we thank them for their time and willingness to be here and interact with all of you today. Huge shout out to Mrs. Garrett and all of you in her AP Stats class for all of your hard work and efforts organizing this event. So the good thing about these, it's all student-led. So at this time, I'm going to turn it over to our student moderators, Samara Benza and Emma Knight.
Morning, everybody. We're going to start off by introducing the panel. First off is Mr. Paul Matthews. Paul Matthews is president of Matthews, Molnar, and Bailey Incorporated, provider of quality engineering and applied statistical counseling and training services for R&D, product, process, and manufacturing engineering organizations. Paul has over 35 years of experience as an engineer, scientist, professor, and consultant. He holds bachelor's and master's degrees in physics from Miami University and Case Western University, respectively, and is certified by the ASQ as a quality engineer and Six Sigma Black Belt. Paul holds 10 patent methods for engineers and scientists. Paul is a member of the American Statistical Association and a senior member of the American Society for Quality. In his free time, Paul races and cruises his sailboat White Hawk on Lake Erie with his wife, Kathy.
Next, we have Mr. Ryan Milwaukee. He's a baseball information intern and is beginning his 5th season with the Cleveland Indians. He began his tenure with the Indians in the summer of 2014, when he spent 2 seasons as a member of the Game Day Guest Services team while still in college. In 2016, he served as a game day intern in the baseball information department before transitioning to the full-time intern role in January of 2017. In his current role as baseball information intern, Ryan is responsible for performing the statistical research that is used in public-facing team communications, including game notes, broadcasts, and the team's annual media guide. He also assists the other members of the communications department with player relations and the media credentialing process. As a native of Westlake, Ryan is a 2012 graduate of St. Edward's High School, where he was a pitcher for the baseball team and was also a member of the marching band. He attended Northwestern University, where he graduated in 2016 with a major in journalism and minors in marketing and film studies. When not watching or playing sports, Ryan is an avid moviegoer and a keen researcher on the Billboard Popular Music charts. Thank you for being here.
Next is Dr. Amy Nowacki. Dr. Nowacki received a bachelor's in mathematics from Baldwin Wallace University, a master's in applied mathematics from Kenston University, and a doctorate in biostatistics from the Medical University of South Carolina. As an associate staff biostatistician at the Cleveland Clinic, she possesses expertise in both study design and analysis of medical research data. She currently is actively collaborating and publishing with a variety of research investigators representing bench, translational, and clinical applications. Teaching is one of her passions, and thus one of her research focuses is statistical education and the communication of statistical ideas and concepts by physicians in both research and patient care. Other research interests are adaptive clinical trial designs and statistical modeling concepts, specifically propensity score analyses and prediction modeling. Welcome.
Next, we have Mr. Jeff Chappell. Jeff graduated from Bowling Green State University in 1992 with a Bachelor's of Science in Actuarial Sciences. Since then, he has advanced his career as an actuary working with Howard Parent Investment Incorporated and for the past 14 years with CBIZ Incorporated. While at CBIZ, Jeff has steadily grown the actuarial consulting practice by helping companies and government agencies understand their future benefit obligations for retirement benefits. Jeff is also on the board of the Eagle Scout Association of Lake Erie Council and enjoys camping, hiking, fishing, and coaching his 3 children.
And last but not least, we have John Holcomb. John Holcomb attended St. Bonaventure University and majored in mathematics. He went on to graduate school at the University of Albany to pursue a PhD in pure mathematics. His first semester, he was assigned to be a TA for introductory statistics and he taught his first class in statistics the next semester. He started to take graduate statistics courses so he could at least know a little more than his students. He earned his PhD in statistics in 1995. After teaching 5 years at Youngstown State University, he moved on to Cleveland State University in the summer of 2000. He has collaborated on many research projects that include stroke rehabilitation, weight gain among college freshmen, bank expansion, and hunger among rural Appalachians. Recently, he has been the leader of Operation STEM, CSU and NSF-funded project to help students in science, technology, engineering, and mathematics to complete the required coursework in pre-calculus and calculus to achieve their degrees. Welcome.
So to start off this program, we would like to ask a question to the entire panel, so just please feel free to start off. Mrs. Garrett says that statistics will always be relevant in a person's life, and statistics will be used in every career. Do you believe these statements to be true?
Absolutely. One of the big problems that we've all got is how to learn how to consume data. You guys know that there's a lot of sources of information out there, and many are not trustworthy. So you have to learn how to assess the information that's provided to you. I teach a lot. About 40% of my business is teaching for corporate clients. And I always provide my students with a long list of books that I wish they would read, but one that I highly recommend is Carl Sagan's Demon Haunted World book. There's a chapter in it called the Baloney Detection Kit. And it's a catalog of all the ways that people can try to fool you. Unfortunately, some people have tried to use it as a guidebook for how to implement these things. But you should all go read that. It all comes down to how to consume data, how to know what's right, what's not right, and how to set up, when you're in a position to run experiments yourself, collect your own data, how to structure those data collection exercises so that you're not going to be misled. Anybody else?
My short answer is yes, also, that everybody's going to be using it. And I guess my comment to add would be that there's a reason that almost every major in college requires you to take at least one statistics class. And I think that's because no matter what you go into, you're going to be able to utilize those quantitative skills.
I definitely agree with that. We didn't have a statistics program in my high school, but when I was in college, one of the classes we had to take as a general requirement was statistics. It was definitely one of the most enjoyable classes in terms of understanding material, seeing the real world implications. Like he said, not just in your career where you deal with the statistics every day in real life, whether you're looking at politics, trying to follow what's going on, engaging in a debate, if you have that background of knowing the data and understanding it, that element of the storytelling side of things as well, being able to not only see the numbers, but see what they mean and what their implications are. I definitely think that holds true, whether it's real life, your career, or any sort of endeavor you're going into.
I might disagree just a little. I think every career is a bit strong about whether you're going to need statistics. I think there will be pockets of places that don't. However, I do think, A, you can't get through a college career without taking statistics in almost every field. And B, even in fields that not every person in that field needs to know statistics, if you do know statistics in that field, you are going to have more options available to you for promotion, for other opportunities than those other people. Even things that are tangentially related, things like nursing, things like physical therapy, occupational therapy. Yes, they need to know statistics to know the therapies that they're using actually work. But a lot of times they just do, they just say, okay, I'm going to do this. But if they actually understand statistics and know statistics, then they're going to have opportunities for promotion, for other jobs in that same field because of their numerical and quantitative skills.
And I would, again, say that stats is very important in about everything that you do. Understanding mathematics and stats and knowing what to do with it, and how to take that data and how to analyze it and how to question things is really important. What I do as an actuary and what the actuarial field does in general, is set insurance rates. So setting insurance rates, how do you know how much to charge a 18-year-old boy who's going to start driving? It's all based on stats. So, So insurance especially, data is very important. So understanding the data, understanding what to do with it is very important.
Our next question is for Dr. Holcomb. How are statistics used in your stroke rehabilitation research project?
So I collaborated, and still do, with people at the Veterans Hospital in University Circle in Cleveland. And what they work with are stroke patients who are sort of 6 months after a stroke, and they're developing therapies to help these patients walk better. And so one of the therapies that they developed was running this electric current through the muscles of the leg so that that person could lift their leg higher and walk better. So even though the therapy is pretty sophisticated, the statistical analysis is not all that difficult. The statistical analysis, one of their outcome measures is something called the 6-minute walk test. So the person walks on a treadmill for 6 minutes, and they just measure how far did they walk. And so the statistical analysis involved a pre-measurement and a post-measurement, and you look at the gain, and you see how if that is statistically significant above zero or above what is considered natural improvement over 6 months, or you compare that treatment's gain to another treatment's gain, the traditional treatment, and those are methods that your teacher, Mrs. Garrett, says you're on the verge of learning right now. You're in confidence intervals and hypothesis testing right now, but the analysis itself was a 2-sample t-test, which is coming up right around the corner for you. And so it's stuff that you learn right in AP statistics. And some of the data visualization that we do are side-by-side box plots that you've already learned about in statistics. And so that's basically, in a nutshell. There are some more sophisticated things as well, but at the heart of it is something as simple as a pre-measurement and a post-measurement.
Our next question is from Mr. Chappelle. You already talked about your insurance portion of your actuarial field, but what are some other places where you could look into if you're looking for a job as an actuary?
Sure. As an actuary, there are 2 major career paths, and so in the actuarial field, of course, insurance uses a lot of actuaries. What I do, I'm a benefits consultant. So as a consultant, companies come to us and hire us to help determine what are the costs of their benefits. And so when I say that businesses have to account for their costs of their business from year to year, so when you have retirement type benefits, someone's going to retire in 30 years, you have to put something on the books today to figure out what's the cost of that benefit in 30 years. So we as actuaries look at life tables. So one of the big jokes in the industry is someone says, well, you know when you're going to die. So I don't know, ask an actuary. Because we look at all the stats. Actuaries put together the mortality tables. So we look at when people die, what were the causes of death. And so all of those things come into play with mortality tables. And so a big part of what we do is analyze future retirement benefits. We figure out what their cost is today, and companies need us to do that for them. So it's a big part of the actuarial field. So you're either doing consulting or you're working with an insurer and you're helping setting their rates. So those are the 2 big areas.
Our next question is for Dr. Nowacki. What is it like working in a field that is typically male-dominated, and how prevalent is gender bias in the field of statistics?
Starting out with a hard hitter here. I'd have to say I've been quite fortunate that I have not run into a large amount of discrimination or bias. It's definitely true that there definitely are a lot more males in the field. I kind of get a double whammy because not only being in statistics, but also within the medical field where there are also a lot more males, although those numbers are changing. I think, though, one of the really nice aspects is this is something that has been recognized by the statistics community and the American Statistical Association. They have a lot of programs, and they even have their own conferences, Women in Statistics, and so they have a lot of opportunities for you to kind of to learn about how to self-promote yourself and how to achieve equal pay and how to negotiate for equal pay. And I think that as long as you're willing to kind of be proactive in that regards, that there are a lot of available opportunities to help you achieve equivalence. I've never really had personal discrimination from any of my colleagues, but I think that it's an area that people are aware of, and I think that the societies, the national societies, are trying to help kind of alleviate any sort of discrimination. But I think that I don't think it's a bad area to go into by any means for women. And a lot of times they will actually seek out for diversity purposes. So it's a great opportunity for women in STEM areas of research and work.
Taking a quick break from the individual questions, a question for the entire panel. What do you think is the most rewarding part in a career in statistics? What would you change about your career?
Well, I could chime in. I don't know about the most rewarding, but one of the things that gives me peace of mind about a career in statistics is basically that you can go anywhere in the country and get a job very quickly. I grew up in Western New York, it's an hour southeast of Buffalo. My father commuted over an hour to Buffalo to work in a GM auto plant, and he was laid off in the 80s. And it was just a terrible time for my family. If any of your families have gone through unemployment, especially through the Great Recession that we're just coming out of, you know what a terrible toll that can take on a family and the psyche of people. And so I just feel gratified knowing that the skill set that I was just lucky enough to acquire is in such high demand that I could go anywhere in the country and be able to get a job pretty quickly. I find that very reassuring. And if this winter lasts much longer, I may need to move. So.
To me, the most rewarding part is kind of problem solving. I think that it's really kind of cool to be able to face real issues that patients encounter and try to come up and develop new medical technologies. The most challenging part, I think, is that you have to be willing to always be learning, because you really are becoming a lifelong learner. They're always coming up with new approaches and new packages and new software, and so it's both a challenge, I think, and a plus. But so you never get really bored because you're always learning. What would I change about my career, if anything? I'd probably give myself summers off. I wish I had gone into academia to get the summers off, because that's one of the downsides, is that we don't have that kind of nice academic calendar. So I think that's probably what I would change.
I definitely agree with the previous points. The most rewarding thing is that if you have that knowledge, you're instantly going to be viewed as somebody who's in the know and somebody who can help out with things like that. I mean, even in a team setting like the Indians, we have obviously our communications department that deals with the stats on a daily basis, but also we'll get a lot of requests from other departments. For example, we have a corporate partnerships department that handles any sort of advertising or any sort of promotions. So almost at least once a week, if not more frequently, we'll get requests to do some sort of research because they know we have that knowledge. For example, we had a company that was looking to run some sort of in-game promotion that happens no more than 4 times a month and no more than 25 times in a season. Can you think of any sort of thing that might happen? So we have to run through and say, let's take a look. So we have to have knowledge of what happens in a baseball game and knowledge of its frequency. So that's all sort of programs and running frequencies to figure out things. So it's very complicated, obviously, but it's something that can make you instantly recognizable to the rest of the departments. It's a good way to make connections. It's a good way to make yourself visible to the rest of the company. One of the things I would change is that, to agree with your point that you're always learning, I wish that I had probably taken more of a statistics sort of basis in college. I learned stats in college. I always thought of myself as being proficient with Excel, but you're never really all the way there with Excel. So I'm still learning. I'm still taking classes outside of work, trying to get better, and always trying to improve. So the earlier you start that process, the further ahead of the curve you're always going to be.
As a consultant, my success in my business depends on my customers' success. And I'm really lucky to be working in this field because the methods do work. And if I do my job right and my customers run good experiments, the methods will deliver for them. And I, as a consultant, I don't do any marketing other than a personal contact. I don't have to advertise anywhere. It's all just by word of mouth. So that part works really well. What I think I would change, I could have stayed in college my whole life, but I have to make a living. So.
This next question is for Mr. Milwaukee. As a journalism major, you must bring a different perspective to the field. So how is your unique background impacting your career in statistics?
It's a very good question to get back a lot. It's sort of, why did you go from this path to this? I think that the world of stats and journalism are inextricably linked in that you need to be able to tell a good story in order to make sense of all the numbers. Data can be coming at you from a lot of angles. It can be sheer enormity. If you're looking at a table that's just filled with numbers, you say, what do I do? And the best, even if you are looking at all those stats, sometimes it's hard to make a clear picture out of that. So if you have that background of knowing how to write concisely, knowing how to put a story out that can impact people of all kinds of backgrounds, all kinds of viewpoints, I think that's always going to be a valuable way to make sure that the key part of what you're collecting in your data gets out to the masses.
Interesting. And then one more question for Mr. Matthews. How do you make your calculations in your job as accurate as possible for your clients on a budget?
I wanted to define the word accuracy first. When you're collecting measurements from any process, you want reliable measurements, and that there are two components to that. They have to be accurate, which means that if you collect many observations, on average, they line up with the accepted reference value, and then they also have to be precise. They have to be clustered tightly around that average value. So the statistics that we check to guarantee reliability are the mean, to make sure that it aligns with the accepted reference value and the standard deviation that tells us about the noise. One of the common exercises that I do with my customers is we run gauge error studies, for example. We run experiments to quantify the amount of variability coming from different measurement sources. In the classic case, you might be looking at a collection of parts that someone's interested in measuring, but many operators can measure the parts on many different instruments with many different measurement procedures, and you have to quantify the variability coming from all those sources. So it takes a pretty sophisticated experiment, not beyond what you guys can do soon, maybe next week. But this is all very, very well defined, very structured, very mature. It's a very mature area, and we're all involved in that to some degree.
This next question is for the panel. If we could start off with Dr. Holcomb. How does your knowledge of statistics affect your everyday life, and how has your view of the world changed because of your statistical knowledge?
So I think that my training as a statistician informs the way that I read the popular media and embrace the new data visualizations that are coming out in popular places like the New York Times, the Washington Post, the Wall Street Journal. I think that that's a pretty exciting development in journalism, is the way that they're using data, to piggyback on what Ryan was saying, to tell a story. Just yesterday or the day before, there was this really cool graphic that talked about looking at hundreds, even thousands of young people and looking at what socioeconomic status they started at, and then where did they end up 30 years later as adults, and looking at how African Americans, even though they may start out in a very high socioeconomic status, the probability that they end up in a lower socioeconomic status is much higher than their equivalent counterpart who is Caucasian. And they have this really cool data visualization that shows these dots flowing into these strata of income. And I just think that kind of stuff is really cool. So that's how it informs my everyday life. I think I bring to it the skepticism that Paul was referring to earlier, the implicit biases. I sort of want to know how the data was collected. I kind of want to know how the questions were worded. All those kinds of things that you learn about in Stat 101 in your AP Stat class. And oftentimes you don't get the answers unfortunately, from the journalistic article, but it makes it more interesting.
To piggyback on the skepticism idea, I can it's definitely made me recognize spin and how it's easy to make the numbers agree with what you want to say, especially in the field I'm in. Our job every day is to put out stats and notes that make our players best and make our opponents look like they're weak. So it's very easy to turn the numbers or set your boundaries just barely enough so that it fits what you want. Whereas a full expansion would sort of dilute the impact of the stats. So it definitely has made me more aware of not to just take everything at face value. Like you said, there's a lot of data out there that is informing the public, but if you don't take it with the angle of what is this telling, what is the sample size, how is this actually impactful, I think it definitely makes you a better citizen and more informed, that you're not falling for anything that's said with the press.
Yeah, I would just like to reiterate that once you kind of know math and stats and what the numbers are, you start looking at them differently when someone gives you information. So being more skeptical about the information being given to you. But it is fun being with friends or family, and they ask you, "Hey, what does that mean?" And you can sit there and explain it to them. You're sitting at an Indians game, and they're like, "What's the BAP stand for? What does this thing stand for?" And you can explain it to them, and they know that you probably know. So your friends and family are looking at you for expertise, and so that's always fun.
But the downside is they always ask me to split up the bill. Like, you're good at numbers, right? I'm like, but I think a healthy dose of skepticism, especially in this new era of kind of fake news, you really need to be able to dig in and see where this information is coming from. There'll be this report that 75% of the people polled agree with that this is the best way to go. And then you look into it, and it turns out they actually asked 4 people, 3 of them agreed. That's very different than if you found out that they did a national survey and they asked 20,000 people and 75% agreed. So really being able to kind of ask the right questions and dig into it. My husband refuses to watch the news with me because he's like, I can't sit there with you. Because there's always, it seems like every news report, they find a new food that causes cancer or this or that, and I'll be like, oh, well, who was their control group, or what did they, and he's like, you ruin it. But it just allows you to really,
she's right.
it allows you to really be able to figure out if this information, if you should act on it, or if it's really something that you can brush off, or something you need to collect more information on.
Okay, and just a couple more questions. If Dr. Nowacki could start off with this one too. What was your first memorable experience with statistics that began your interest in your specific field?
When I was in graduate school at Kenston, I actually went there because I wanted to go into operations research. Statistics was actually not even on my radar. I went there, and then I had an amazing statistics professor, and he actually pulled me onto a project. He said, would you like some real life experience? Because I kind of had commented to him, it seems like a lot of numbers and formulas. Where do you actually use this stuff? And he said, I'm failing you if I haven't shown you where this is being used. He said, I know this is going to be more work. Come join me on a project. And so I started working with him at the Greenville infertility clinic. We went there and we met some couples who were having troubles getting pregnant, and so they were interested in doing in vitro fertilization. However, at the time, and I don't know how much has changed since, but this was not covered by insurance, and each cycle was about $10,000 out of pocket for the couple. And it often took a number of cycles in order for them to have a successful pregnancy. And I was really moved by, I got to talk with these couples, I got to see how difficult this was, and I met with some doctors, and they wanted us to collect some data and try to develop a model to predict the probability of a successful pregnancy. Taking information from the woman, taking information from the man, taking information about how many times they've tried, the different medical information. And we tried to put this all together so that we could then accurately inform a couple. Because that would really help them know if I have a 85% chance that this is going to be successful, I might be more inclined to go through it because it's a lot of toll on both the woman and the man. Versus if I look at this and I know I only have a 12% chance of a successful pregnancy. And so that was really kind of my aha moment because I had a chance to actually help people. I love the medical field, but I faint at the sight of blood, so I knew I couldn't be a doctor in that regard. So I thought, well, I'll do the next best thing, and I'll still help people, but I'll do it from a non-blood position. And so being a statistician was really a cool way that I could contribute in that.
My first stats story, I'll go back a little bit further in my life to first grade, actually. We were in a first grade class, we were learning about geography or something, and my teacher was telling us that Texas was the largest state in the country. And the 6-year-old me, in the rude way that only a first grader is when they don't actually mean it, I was like, no, it's Alaska. And my teacher said, no, it's not. And I got yelled at that day. But that night, I went home and pulled out my own map and I took it to school the next day. And I was like, oh, see, here it is. And then she's like, oh, you're right. And so from that point forward, I guess I always had some sort of inclination of knowing the numbers and knowing what they mean sort of helped me from a trivia perspective at first. But then once I learned that there's more to that, that you can always be getting ahead by knowing the numbers, it's definitely something that I enjoyed moving forward. I still do the trivia side of things. I was on the trivia team in high school and college. I still I play HQ every night. Anybody needs to but it's always gonna come in handy, and I think that curiosity from an early age is one of the key factors that I hope all the colleagues here would share.
Great. And this time we'd like to give you an opportunity to talk about some of your achievements. So what parts of your statistical careers are you most proud of?
Do any of you have a question? What from our careers that you've heard so far sounds interesting enough? You guys should ask. You guys should be quiet.
Well, we'll have
Who sounds like they have the most interesting job here so far?
I can say that.
We'll have a 10-minute intermission in a couple of minutes, and then after that intermission, then all the students will ask questions.
Well, I can chime in. One of the things that I found rather rewarding was working on a paper about 15 years ago. So I was working on a statistical project, and what you don't necessarily realize, especially when you're taking EP stats, the data that you're working on and the data that you're entering into your TI calculator is probably clean, meaning that it's been checked, the data all is valid, it's realistic. You might be looking at beats per minute and seeing values like 65 and 75. You're probably not seeing a value of 981. But on many statistical projects, when you first get the data, you have to do some preliminary analysis. You have to clean it. You have to make sure that what you have is real. And a lot of times you use the methods that you're used to in AP statistics. You make box plots, you make stem leaf plots, you look at the mean, you look at the standard deviation. What? I have an age of 991? That's not possible. So what do you do with that data value? And so I designed this project for my students where I gave them a data set and it had bad values in it, like an age of 991. But then if they found that record number or that ID number, I made up on the web a fake medical record. And they could go back and look, oh, that patient's age was 91, not 991. And so they could clean the data by going back to the original data point to help give this idea that working with data isn't as clean as it seems in intro stats or AP statistics or even in a graduate level stat or the data sets that you see in your textbook. And in some sense, that's kind of where data data science is gone today. Now you hear buzzwords in our field, and maybe you're a little young for this yet, but there's things called data analytics, there's data science, there's business analytics. It's all working with data. But a lot of times what companies do is they give you a data dump, and that will contain errors. And you have to sort of feel through that and decide what can I use for the analysis of what can I fix, what can I fix. And so I think that's a really interesting part of the field that does take up, sometimes that can take up to 85% of your time, and then the analysis is easy. Oh, you run your regression, you run your t-test. That's fun, that's easy, but getting through the mire of figuring out A, what you have, B, what it means, A, how is it collected, and then figuring out your analysis plan. So I think it was really neat to try to give students a feel for that process, even at the undergraduate level with this data project.
Yeah, I was saying, working with the business field, helping businesses solve a problem, or realizing that they have a problem, or realizing that they need something solved. Sometimes they come to you with one set of problems, and you said, well, it sounds like your problem might actually be this other thing over here. So understanding that and helping businesses to solve problems, there's always something new coming in the door, which makes it exciting as a consultant and helping businesses and government entities, whether it's a police station, fire department, city, state, county. They all have similar problems, but understanding and helping them solve their problems is what's rewarding in what we do. So.
What am I most proud of? I think my answer would depend on who was asking the questions. If I was talking to my boss, I'd probably say I'm most proud of having published 77 articles. If I was thinking more in my personal most proud of, I would say I teach physicians, and we know how busy physicians, residents, and fellows are. And I teach a class. None of them are required to take. You don't get anything out of it other than joining me on an adventure through statistics. And it is at 7 a.m. in the morning. They do it before they start seeing patients for the day. And I have over 80 people come at 7 a.m. to learn statistics they don't get anything else out of it. They're not required to be there. And so to me, that is the most rewarding aspect, is that to see other people see the joy in statistics. That's fun.
If we're talking about an instant reward, it's definitely the feeling you just described when you finish through all the data dump. I equate it to when you close all the tabs after you finish that research paper. That's just instant. Thank goodness it's done. But if we're talking about a reward, it's always going to be when you're helping people. That feeling that you were able to help someone achieve their goal by what you were able to do. I haven't, obviously, when we're dealing with something as entertainment side as baseball, you're never going to feel like you changed somebody's life or anything like that. The most rewarding experience I've had was I was a student assistant teacher at an elementary school when I was in college, and we were dealing with kids that were on IEPs, which is an individualized education plan. And the first time that one of the students I was working with got 100% on this times table, that felt really good. That was something, you worked with him, he was able to get to that point, and now maybe he'll enjoy math moving on forward. So that sort of feeling of always helping someone, whatever that field might be in, is always probably your most rewarding experience.
Just quickly, I started out of college working at GE Lighting, which was a great place to do physics, and that's where I learned I don't have any physics degrees. I learned all of this out of necessity. I was working in an environment where it was critical that you do this stuff. GE realized that people coming out of college had not been trained in these methods adequately, and they threw us immediately into all this internal training. I forget where I was going to go with that. There's so many situations in which you'll find yourself, with statistics training, you're going to find yourself in a situation where you could have someone with really, really strong math and stats skills, but light on the engineering and science side, and then you could, and there will be people that are very, very strong in the math and the science and engineering pieces, but they don't know how to talk together. And that's one of the places, one of the niches that I found to work in at GE and then beyond GE, I kind of became that interface person where I know enough of the statistics and I know enough of the engineering and science that I can connect the two groups together. That's my role as a consultant, is to make sure that the engineering and science people have their statistics covered and that the statisticians have somebody representing the engineering and science people. So I'm not really good at any of those things, but I can do a little bit of all of them.
At this time, we're going to take a brief intermission. We encourage students to come up and introduce yourself to the panel and take advantage of the refreshments in the back. When we come back in about 10 minutes, we're going to have student questions.
So we're going to bring right now we're going to give Mr. Milwaukee, a before where he has a couple of trivia questions and then a wrap for you guys.
So I brought 4 of our promotional items from the last year or so over. So in fairness to those of you that aren't the biggest baseball fans, we'll do 2 of them by random chance. We'll do 2 of them by true Indian science in the group here.
Did everybody get a raffle ticket?
Yeah. So 2 raffle items will be these blanks we gave away last year. We also have bobblehead and our replica trophy from 2016. So, first question is if, for those of you who have been paying attention to spring training, which of our Indians players has already hit 2 grand slams in spring training this year?
You know it, stand up and say it.
The answer might be right in front of you.
Is it goodness?
No.
Oh, I don't
Yago.
There you go. Easy as that. The blankets will be the raffle.
Oh, okay.
All right. This one won't be as easy as looking right in front of you, but it should be an easier question in terms of gettability. So this trophy is the AL Championship trophy from 2016. Do any of you know what city we won it in?
Toronto.
That's correct. All right. So now the mix these up well.
need a good random selection.
Yeah, exactly. There's a good sample size in here.
Anybody crumple up their tickets?
All right. They all look clean to me. All right. So first one is 437. I'm assuming they're all 589. Yeah. The other one, 437. 493.
Who was it?
That's his lucky day there. Let's try 437 581. There you go. All right. The other thing I have, if you guys want to pass around and take a look at, is the 2 main things that we do on a day-to-day game basis is we write the notes and stats that the broadcasters receive and the media they use for their stories and their broadcasts. So the packet on the left is our pregame notes, and then on the right here is a postgame note. So watching a game and saying what happened. So if you guys want to pass those around in like different directions, just to get a glimpse of the sort of stuff we do on a daily basis. And if you have any questions.
Ryan, do you think you could work into one of the games where you give a shout out to Kenston?
We'll see if any of you or any family members have birthdays coming up or anything like that. I can pass it along to Rosie, one of our broadcasters. He always gives shout outs. Well,
Okay, so at this time we're going to open up the floor for student questions. So if you have a question you'd like to ask, a single member of the panel as a whole, stand up, introduce yourself, and ask the way.
Okay. Hi, I'm Tyler Howell. I plan on going into a medical field, probably going to med school. And how can statistics help me within my field, pretty much? Like, just all the whole medical field.
Thank you, that's a very specific question. So I teach a lot at our Cleveland Clinic Lerner College of Medicine, which is a 5-year program specifically geared towards people who are interested both in medicine and research. It is one of the only, it used to be the only, I'm not sure if it, one of the only free medical schools in the United States. Just throwing that out there. But it's very competitive, obviously, for that reason as well. We have students who come in with all different types of backgrounds. Most people think, oh, I have to be like a pre-med, or I have to be a biochem, or something like that. And that's actually not true. When I look at the majors of the people who come into our med school, we have everything from piano to, we've only had one statistics major, but that's just because a lot of them aren't then interested in going to med school. But and I loved that student. I was my favorite student the whole time. I think though that it is something, having the statistics either degree or would help you stand out, or a minor at least, or having taken some statistics classes. I think that if nothing else, all those applications kind of look the same. That would be something that would stand out, because it's not something that everybody applying to med school has a minor in statistics or even a degree in it. And it's a skill set that they recognize, especially at research institutions like the Clinic. They realize that this is a skill set these physicians need to have. And so I think that you can't hurt yourself by taking minimally at least 1 or 2 classes, but I would even encourage you to go beyond that, and I think it would do nothing other than help you stand out in that application process.
Can I comment on that real quick? Next month, I'm going to see Amy and John at the American Statistical Association Spring Conference, and I like to go to those because I'm not a real statistician, and it gives me a chance to hang out with the real ones, and I can learn a lot from them. One of the things that's really interesting with American Statistical Association is, you guys know what fraction of the membership is medical related? Is it 60%?
It's a lot.
It's a huge fraction of it. And at lunchtime on our break, one of the things that I always find interesting is listening to the statisticians complain about the MDs they have to work with. Because the MDs are supposed to know the science, but they don't know the scientific method all that well. And it's these guys that keep them honest. So the stories that they tell are interesting. I think the seminars are worthwhile, but I learn more at lunchtime, and I'm always careful of when I sit. Because the stories that they tell are really interesting, really practical. So I think that everybody in the medical community would benefit significantly if they did have more statistics training. It would be much easier to work with.
And I'll just chime in real quick. One thing to realize, if you want to make the world a better place, and one way to do that is by studying disease and finding a cure for cancer and so forth. And we need physicians. But that's not the only way to do medical research. And so there are other avenues, PhDs in biology, PhDs in chemistry. Research careers in medicine don't necessarily require the MD. And so studying statistics and learning the research method can lead to a career in that regard. And when you go to college, wherever you go to college, and whatever major that you choose, look to see if there are research opportunities for you as undergraduates, either during the academic year or during the summer. There are a lot of programs that will pay you the equivalent of a summer job, and you can do research over the summer, which looks great on your resume, will help you get into grad school or help you land that first job when you graduate. And so there's lots of opportunities out there wherever you go in whatever field.
Yeah, we take, I work in the Lerner Research Institute at the clinic, and we take about 40 to 50 undergraduate students each summer, which is what you're talking about. And they get paired up with PhD researchers, bench scientists, and get some experience. It's a fabulous thing to add to your resume. And your parents would be happy to be back in the Cleveland area for the summer. So.
Thank you all for being here. My name is Chris Becky. Looking back at your education, both high school and college, is there a class there that really stands out to you as memorable and applicable to your careers now? This is for everyone.
I had the benefit. I went to West Geauga, and there was a teacher there, Lou Meingold, who was the best teacher I ever had. I had him for geometry, I think in 7th or 8th grade, and in calculus as a senior. And his expectations were so high, he beat the crap out of us. But he was the best teacher that I'd ever had. When I started in college, my advisor, George Arfkin, was another famous math physics guy. The fundamentals, the math and statistics fundamentals, and the methods that I got from them, the learning math and stats, you can do that for their own ends, but learning those methods also improves your writing skills, your logic skills. So that's an emphasis of the American Statistical Association. We have this quantitative literacy program where we try to push these methods into the elementary schools, into the high schools, just to teach. In addition to math and stats, it's about thinking, how to do logical thinking, statistical thinking. Wanted to repeat the question. I think I got off track.
Outside of, obviously I used all my statistics classes, but outside of that, probably the most beneficial class that I took was public speaking, communications. Because I'll tell you what, when I went to interview, statisticians in general are not the best at communication. And people were like, wow, you're actually making eye contact, you're talking, you're looking at, you're personable, are you a statistician? Like, they were blown away. And I can't tell you how many repeat collaborators I have in the clinic because they're like, well, you're easy to talk to, I can understand, you put it in words that are everyday English. And so being able to really speak and taking a public speaking class or being able to write and communicate your results, so important.
I'll actually piggyback on that in two different camps of what was important to me. On that end, I took an acting class in college that was surprisingly helpful. First of all, it got you out of your comfort zone, got you in front of people, like talking and having to make eye contact and showing body language, which are all things that you have to use on a day-to-day basis when you're working with people in any sort of setting. It also was good for our memorization skills. When you're working with a lot of data, it's easy to lose your track or lose your spot. You got to make sure you can have good focusing skills, so it was good for that. In high school, my math teacher, Mr. Bosley, I had 3 classes. I had for Algebra 2, Pre-Calc, and Calc, and he was a very tough teacher in the same regard that Paul was talking about, in that he expected and got the best out of everyone. So even if it's abstract calculus concepts that I'm not necessarily using today, like pushing through, making sure that the work is complete, not just getting it done, was very important. I think I want to get my stats correct because that's why we're here today, but I think there were 22 of us in Calc, and I think 21 ended up getting 5s on the AP exam. I think the other one was a 4. So he did a very good job at getting the best out of us. So if you can take out of the class hard work at all times, you're going to reap the benefits of that. I think that's an important mindset to have.
Yeah, I would say reiterate with that math and then writing. I never took writing seriously in high school and college, and now I probably write more than ever. So learning how to write, very important. The math comes easy. Actually writing it and communicating it is hard. So.
Yeah, I'll just piggyback on everything they said. I think the communication skills is critical. One of the questions that you had that you gave us was how do the projects find you, or how do you find the projects? And my answer is they find me. It's like Amy said, you have all these repeat customers because if you can explain the statistics in a way that the client or the researcher can understand, they want you. And I've never advertised for more work; it just finds you. And I was blessed with fantastic math teachers all the way from 7th grade up through high school, and a fantastic English teacher who taught me to public speak, who taught me how to write, who I stayed friends with. I got married a year and a half ago at age 50, and she was at the wedding, you know. So I've stayed in touch with her all these years. And she taught me to read critically, and that's very related to analytic skills that you need in statistics.
Hi, my name is Erin Best. I was just wondering if you could talk more about what are the goals and what is the purpose of the American Statistical Association?
And is there any way for high school students to get involved?
There is so the American Statistical Association is a national organization that promotes statistics from the student level to the career professional. So if you go to amstat.org, you will find information about the American Statistical Association. There is a student membership. Usually it's for college kids, but I don't see why a high school kid couldn't join. It used to be $10. I think it's $15 now a year. And you get a subscription to Amstat News, which is a monthly magazine that talks about careers and statistics quite plentifully. So it really could be a benefit to you. There's another website that they sponsor called thisisstatistics.org, and you can find information about salaries, careers, how statistics is used. There's some really flashy videos.
She's got the handout from that site if you're interested.
And the juniors from last year, that's the site we visited when you guys did the project at the end of the year. So yeah, I will leave these back there.
Paul or Amy, do you want to chime in more about ASA?
I was going to bring up ASQ.
Oh yeah, please.
There's another organization called American Society for Quality, and they address business needs, but it's all businesses. It's banking, hospitals, manufacturing. Everybody's covered under ASQ. Their scope is a bit broader than ASA's, but about maybe 30 or 40% of what they're interested in is applied statistics and its use in those other fields. So there are a lot of, for example, the conference that's coming up next month is a joint ASA-ASQ conference. I have many students, customers, who've earned certifications under ASQ. That's one way you can get recognition in the community. And you would need at least a college degree to do that, so that'll be open to you guys at some time. But these certifications require maintenance. You have to every 3 years reapply to maintain your certification. For that purpose, at Lakeland Community College, every month I hold a Quality Managers Network group, and it draws not Amy's 80 people, but I see about 20 people each month. We're there voluntarily. It's free. There's coffee provided. The school gives us coffee. But we talk about, it's mostly applied statistics methods. Next month's meeting is on, you guys all know the normal distribution now. When the data aren't normal, but look fairly well behaved, what do? And in many cases, you can do a variables transform. You can take a square root or a square or a reciprocal or a log and make the data normal. And then all the special methods that apply, that require normality are applicable to these non-normal distributions. That's the topic for next month. I think that's something that you guys could handle.
So the ASA is kind of a national organization that really is there to help support statisticians in their various needs and capacities. So, for example, a lot of us are always learning new techniques, and so it's a great place we can go as statisticians to get extra training. Also, it's a place for people in academia where they can present their research. So I present my new methodologies at this conference, and that's sort of one of the expectations of my employers, that I will disseminate my methodologies. It's also a great place when I was graduating from graduate school. They have job career centers where you can interview with prospective employers. So it's a great place to help you find employment. We also have not just the national one, there are local chapters. So So with the national one, there are large sections, like I'm the chair of the Teaching Statistics and Health Sciences section there. But we also have local chapters, and Cleveland has a chapter. John and I are both on the executive committee there, but we have opportunities for local statisticians, but not even, students come to these as well. But we hold workshops where we'll learn new skill sets. We have one coming up that they're mentioning, like in the end of April. I'm drawing a blank.
Data mining.
Data mining. It's on data mining. So, and first you should, if you're ever interested, just ASA and then just put Cleveland chapter. Just Google it, and it'll pop up, and it'll give you information. But they're very affordable for students as well. But it's also a great networking place. And so this is just a society, or a way for you to kind of interact and talk with other statisticians and get to know more people.
Well, as actuaries, of course, there's groups. The Society of Actuaries, the SOA, regulates the exams and the exam process. And as an actuary, you have to keep your continuing ed up. So they expect you to go and learn and keep learning every year. So you have to have a CE, you have to register with SOA, and then of course there are other organizations that are off of that. So there's the American Academy of Actuaries. There's an organization called ASPA, that's the American Society of Pension Professionals and Actuaries. So that kind of covers everything in retirement pension. So there's a lot of different groups out there, but the SOA is the main one.
So that is about all the time that we have for the speaker series. Thank you all